In today's lesson, we're going to be learning about the real basis of proofs. But before we do that, let's just take a look at what a proof actually is. A proof is an argument that shows that some statement is true. A proof is an argument that shows that some statement is true. Before we see how to create our own proofs, though, we need to learn about one more thing, and that is called a conditional statement. A conditional statement. Conditional statements are statements that have the form if something, then something else happens. If you go out into the rain, then you'll get wet. If you don't go to sleep, then you'll be tired. It starts with something that you have, and then it comes up with some conclusion, something that happens because of that first thing. Now, when we're looking at conditional statements, they're not always going to be in this exact form, but they're always going to have these same parts. They're always going to have if some given, something that you start with, then you'll end up with some conclusion. Let's take a look at an example. How about the sentence, when you don't sleep, you are tired. When you don't sleep, you are tired. This is a conditional statement, even though it doesn't look like the if-then. You can very easily take something out of here, take it as your given, something you start out with that you know, and then come up with an ending. Well, you know when you don't sleep, then you're going to be tired. So I can take my given is no sleep, and that's going to conclude with conclusion. That's going to end with tired. And if I take those two things, I can just take my given and put it in front of my if, and take my conclusion and put it right after my then. So if I get no sleep, then I'll be tired. That is all, if I get no sleep, then I'll be tired. That is all that a conditional statement is. It's just going to have if something that I start out with, then I'll end with something else. And again, it doesn't always need to look like if and then, but it's always going to have these parts. This given, which is your if, and then this conclusion, which becomes your then. Another thing to keep in mind is that conditional statements aren't necessarily always true. So if I get no sleep, then I'll be tired. That's probably pretty true. But what if we take a look at something like this? What about the conditional statement if a polygon is four-sided, then it is convex. If a polygon is four-sided, then it is convex. This is a conditional, but it's not necessarily always true. I can very easily come up with a four-sided polygon that is concave. And if it's concave, well, that means that it's not convex. Look, that was another conditional statement. So if a polygon is four-sided, then it is convex. Well, I just disproved that. I just proved that that is not true by showing you a counterexample. Hey, if a polygon is four-sided, it's definitely not necessarily convex because I just showed you a four-sided polygon that is concave. What about this conditional statement right here? And this one, it's not going to be in my traditional form, but I'll show you how to get it to look like that. So, adjacent angles have the same measure. Well, at first, this doesn't really look like an if-then, but I can take the parts. I know I have adjacent angles. If I have adjacent angles, it is saying then they have the same measure. So if I just take these two parts, I can really make it into an if-then conditional statement. If ADJ, I'll do for adjacent angles, then they have the same measure. Well, here's my conditional. This was my given. This was my conclusion. Is this a true conditional statement? Well, if we take a look, I can come up very easily with adjacent angles such that they are the same measure, right? These two angles are right next to each other. They're both 90 degrees. Those are adjacent. But it's just as easy to come up with a counterexample. If I take this perpendicular line right here and I just scoot it over like that, well, now I have adjacent angles. These angles are right next to each other. But you can see that this angle in pink is quite a bit bigger than this angle in green. These are adjacent angles, but they do not have the same measure. So again, this is a false conditional statement. Conditional statements can be true or false, and if you come up with a counterexample to it, then you know for sure that it is a false statement. Finally, why do we care about conditional statements? Well, the thing is that every single proof, every single theorem that you prove is going to be in the form of a conditional statement. Every single theorem, everything that we prove in this class will be a conditional statement. Everything with a G that we prove in this class will be a conditional statement. It will always look like if some given, if something that we have is true, then we'll end up with something else. Every single thing that we will prove is going to look like this. And that's why conditional statements are so important to the idea of proofs. The given of a conditional statement, the if part, is where the proof begins, and the conclusion is the place where the proof ends. It's the goal. It's what you want to show is going to be true by the end of the proof.